Welcome to MES e-learning channel. In this video, we will see how to find resultant of a concurrent force system. So first, we should know what is concurrent force system. If a number of force is passing through a single point, that is called as a concurrent force system. So we are going to find out the resultant for this particular force system. So to find the resultant for this concurrent force systems, we have 5 steps. So we're going to see the detailed steps, what are the steps required for resultant, and step 1 will be, the step 1, we have to find Rx, this is will be equal to summation of f of x. F of x is nothing but all forces along the horizontal x axis. All the force along the horizontal x axis. Step 2 will be Ry, that is summation of f of y. That means all resolved force along the vertical y axis. Now we have to find, at step 3 we have to find the resultant. Step 3 resultant, that is R. So R is nothing but resultant. So from this we want to find out the magnitude of the resultant. Magnitude of resultant force. So the force is given by the formula given by R will be equal to root of summation of f of x square plus summation of f of y square. To find out the resultant, this is the formula, root of summation of f of x square plus summation of f y square. So once you find out this resultant, the step 4 will be or to find the direction of the magnitude, direction, that is theta, angle. Inclination of the line of action of resultant force, with horizontal axis. So we are going to make the inclination of the magnitude of the resultant with horizontal x axis. So it is given by the formula tan theta will be equal to mod of summation of f of y divided by summation of f of x. So finally theta will be tan inverse of f of y divided by f of x. So this is a mod. So if f of x or f of y will be negative, if you found out it is to be negative, so in theta we have to take it as positive. Okay, so in f of x or f of y will be, if it's found to be negative, while computing this theta, direction of the magnitude, we have to take it as negative because we are using a modulus sign. So the step after completion of step 4, we have to position it, the resultant. This last step, that is step 5, position of the resultant. So the resultant may be lying in any 4 quadrants. If you know we have 4 quadrant, first quadrant, second quadrant, third and fourth quadrants. So resultant might be lying on any of the 4 quadrant. To place the position of the resultant, we have to observe the sign of summation of f of x and sign of summation of f of y. Based upon this, we can say that the resultant will be in the fourth quadrant, first quadrant or second quadrant, whatever it be. Suppose if you have summation of f of x is positive and summation of f of y is also positive, then the resultant is first quadrant. The summation of f of x is negative and summation of f of y is positive, then the resultant is second quadrant. If the summation of f of x is negative and summation of f of y is negative, then it's in third quadrant. If the summation of f of x is positive and if summation of f of y is negative, then it's in fourth quadrant. So based upon the sign of the summation of f of x and summation of f of y, we are going to place the position of the resultant, and after that we are going to place the with the inclination what we have found it. So using these 5 steps, we can find out the resultant of the concurrent force system.